All right. Hi, everyone. Sorry I can't be there today, but I did want to hop on here real quick and teach you what we were supposed to learn today. Basically, this whole unit is about bonding. We are going to take elements and put them together. So we could have sodium and we could have chlorine and we will put them together. Now, a couple ways they join is they either give their electron away or they share their electron. And so one of the first things we need to learn is how to identify what type of bonds these chemicals form together. Because if they're one type of bond, which is called ionic, you name them one way. And if they are another type of bond, which is called covalent, you name them and write them another way. So the first thing we need to do before we proceed of how to name chemicals is figure out what type of bond they are. Two pretty simple ways to do this. The first is using our periodic table. So I'm here on page 13 in your packet, and page 13 in your packet has a periodic table that looks like this, and a little key or legend right down here at the bottom. Let's start by just labeling our metals with an orange color. Okay, so this orange color, all of these elements in this area are the metals. So I'm just going to quickly color them orange. Okay, these are all metals. Now be careful not to include hydrogen in there. Hydrogen's the one little chimney stack up here on the corner. That is a non-metal. So let's do our non-metals next. I'm going to do non-metals in purple. Hydrogen is a non-metal. And then all of these elements on the far right side of your periodic table are non-metals. Metalloids, we're not going to get into very much, but metalloids are kind of these ones in between. They kind of make that staircase, but we're not going to talk about those much. Okay. So up here are the notes that you need to know. So an ionic compound, ionic is our first type, ionic. Okay. That is when you have a bond between a metal with a non-metal. So an orange with a purple. And then our other type of bond is a covalent, and that is when you have a purple, a non-metal purple with a non-metal purple. Okay, so let's try some. Here we go. First one. I have calcium, Ca, that's a capital C, lowercase a. It means that the chemical gets divided right between the capital and the lowercase. So this part I have to find, and then this part I have to find. So I go up to my periodic table, I try to find calcium. Calcium is right here, number 20. It is orange. So I'm going to go down here and color calcium orange as well. Okay, then let's go to find my other chemical, which is Cl. Here we go. Here's my Cl. Chlorine is over here, which is purple. So I'm going to color my chlorine purple. Okay. According to our notes up here, when we have a orange metal with a purple non-metal, those two, metal and non-metal, make an ionic compound. So I would just write ionic. Then our next one, we have capital C, capital O. Every time there's a capital letter, that's a new element. So we know it gets divided between the two capital letters. So I have a C with an O. So I'm going to go look for this on my periodic table. I have a C right here. I have a O right here. They're both purple, which means they're both non-metals. So purple with a purple. And on my notes here, purple with a purple means I have a covalent compound. So let's label that covalent. Oops. All right. Now, the only other part we have to talk about is when there are three or more compounds. How do I know there's three or more? Sorry, three or more elements. How do I know there's three or more elements? Well, I have three capital letters. And what happens with the elements that have three capital letters, or sorry, the compounds that have three elements in them or three capital letters, is this part right here bonds covalently, and this part bonds here ionically. And so we end up getting a compound that has both ionic compounds and covalent compounds. So we just write the word both. All right, so that's the first way of how we do this. The next way is we use what's called the electronegativity differences. Differences, the word differences means subtraction. So we simply take the electronegativity values and subtract them. And where they land on this scale tells us if it's ionic or if it's covalent. So let's look here. On my periodic table right here, I have all the electronegativity values. So fluorine over here has an electronegativity value of 4. And potassium over here has electronegativity value of 0.8. So those will be the values you will use. Those are also on your blue periodic table reference sheet. So here we go. I have a compound made with magnesium and nitrogen. Okay, so I can go up here, find magnesium's electronegativity value is 1.2, and nitrogen's electronegativity value is 3.0. So let's put those in the box. 3.0 for nitrogen, 1.2 for magnesium. When you subtract these, they will always end up being a positive answer. So it's the big number minus the small number. So it's 3.0 minus 3.0 minus 1.2, and that will equal 1.8. So then I go up here and look at my electronegativity difference values. 1.8 falls in the range between 1.7 and 1.3, so therefore it is ionic. And then I would just write the bond type ionic. Okay, let's look at the next one. K with F. K with F. So potassium with fluorine. So I'm going to come up here, find my potassium value is 0.8. And I'm bonding it with F. And my F value is 4. So 4 and 0.8. So 4.0, 0.8, 4.0 minus 0.8 gives me a difference of what? 3.2. And 3.2 falls in this range. I promise they aren't all going to be ionic, but these two examples are. You'll probably get some here, a lot here, very few here. Okay, so I would write that this is ionic. All right, hopefully now with this little introductory video, you can go now and complete some of these. On page 15, you could probably complete. Page 16, you can complete. And that should do it. So 15, 16, get those done for me for homework, and we'll call it a day. Thanks, guys. Bye.